Okay, here we go. We're doing the natural log function integration. So last class we did the derivative of the natural log, and we said natural log of x is 1 over x. And then if we had something else besides x, another way to think about it is natural log of f of x. So that just reminds us to do the chain rule, that we're going to have to go back in if we have anything other than x. If we've got 5x, x squared, we got to come back in and do the chain rule, as well as the 1 over whatever we're taking the natural log of. So it would make sense, since we understand how antiderivatives work, it would make sense now that we would have an integral, a way to integrate 1 over x. Because so far, we've used the power rule to undo, I'm sorry, we have a method to undo the power rule, right? So if we were taking the integral of x cubed, we would add 1 to the 3, and that would be a 4, and we would divide by that, right? And then, of course, the plus c. But when we have the integral of 1 over x, right, which is x to the negative 1, and we add a 1 to it, we're like x to the 0 plus c. All right. No, we haven't been able to, x to the 0, and not only just x to the 0, but x to the 0 divided by 0, right? That undoing the power rule doesn't work for when we'd have 1 over x. So thankfully, we've got our new antiderivative. We know we can integrate 1 over x, and it's going to be equal to natural log of x. So we're going to use this, and what's really fun is that we can use it to integrate tan of x, right? Because as soon as we have something in the denominator raised to the first power, we can use the natural log. I'm going to check to make sure that this is going, and it is going. Okay. So right now, if you wanted to, it's going to be a long lesson, so maybe you can save this for later, but I will just kind of do a reveal. If you wanted to, real quick, do tan of x, right? Sine over cosine. What's our u going to be? What's our du going to be? Now we know how to integrate when we've got 1 over something raised to the first power. So pause the video, see if you can do it, and come on back. All right, so there we go. If you want to challenge yourself, cotan is going to be the same thing as tan, right? We're just going to flip that cosine over sine. We're going to do it the same way, and we are going to use our integral of 1 over u. And so if you want to pause that and try it, you can. Or like I said, this lesson is going to be really long. You can always come back later and try that. I'm going to go ahead and reveal it just so that it's here on the video if you want to come back. So close your eyes if you're not going to want to see it. All right, ready, set, pause. Do it if you want to, or come back. All right, now to integrate secant and cosecant, there's kind of a little trick to it. I'm only going to show you the secant one. Once again, you can try all day if you want, but until you know like the little trick, you're not going to get it. So basically, we would change this, and we'd multiply by 1 in disguise, right? Secant x plus tan x over secant x plus tan x. And when we do that, our u becomes our denominator, right? So we can use a natural log, and then our du is just happens to be there, which is just beautiful, really cool. Cosecant's done in a very similar way. All right, so fun, we can do that. And I think this one is just showing us, there we go, showing us the same thing. I want you to note that the integral of tan, when we did it, what did we get? We got negative natural log of cosine of x. You could put that negative up to as an exponent, right? Cosine x to the negative 1, and that would be 1 over cosine, which would be secant, and that's why you will see it both ways. You do not see it here. But you will see it both ways. You can do that. All right, so let's go and let's see what we're going to do next. All right, so we've got the integral of 10 over x. And what's our u going to be? You got it, right? Before we even do the u, let's kick that 10 out. So what I'm going to do is pause. You know how to do this. Pause it, come back, check your work. All right, did y'all get it? Do the big reveal? Okay, pretty straightforward. Let's build on that. All right, here, once again, we're going to kick out that 7, right? we're going to set our u, we're going to find our du, ready, set, pause it. You can do this and come back. Okay, you're back, so you kick the 7 out, right? You set your u to be 3x plus 5. You found your du. You kicked, let me get rid of this, you kicked the 1/3 out, right? And then you set it up, and then you apply the integration of 1 over u is natural log of u, then you plug u back in. Okay, let's just get rid of this. You plugged u back in, and you remembered your plus c. All right, so pretty straightforward, right? It really is a very straightforward lesson. There's a few little fun things that we'll get to, like this. All right, what I have here is, okay, you shouldn't really be seeing this. So sorry about that. Let's just put a big old rectangle on there because that should be covered. Oh, well, you saw it already. How do we get to that? Let's talk about it real quickly. I am looking at something that if I make my denominator be equal to u, man, right, my du is going to be 2x, and how do I account for all this mess up here? So whenever we're looking at a polynomial divided by a polynomial, we can always do polynomial division, right? And when we do, especially if our bottom number or our bottom power is less than our top power, right? And so go ahead and see if you remember how to divide using polynomials. You did it last year in Honors Pre-Calc, so it should be fresh. All right, pause, do it, come on back. Okay, so hopefully you got the x minus 3, and that's where this came from. So we've got our x minus 3, and then see our remainder, our x. We're going to put that over what we divided by the x squared plus 3. Now we have an integral problem that can be split up into 3 parts, right? The first 2 parts are easy. Let's focus on the second part. Can you see where our u is and what our du is? I know you can. So I don't want to bore you. Go ahead and pause, do it, and come back. All right, so let's look at this. Oh, it's not going to let me get it away. All right, so our u is going to be the x squared plus 3. Our du is going to be the 2x. We're going to kick that 2 over. And then we're going to notice our x dx is there waiting for us, right? It's going to be right here, x dx. So we're set up. We're good to go, aren't we? And so let's get rid of this and see what else we've got. So then we set up just that part of it. And now I'm going to reveal all of it. So we go ahead and integrate the first part, second part, and then there's our third part. And of course, we're going to remember the plus c. So the only thing right now that we've got to add on to, besides just using the integration, our new integration rule, is long division. Could you see long division on the test? Sure. Could you see long division on the AP exam? Sure. Why not? So if we need more practice when I get back in class, and where you get back in class, that would be great. All right, some of you may have been thinking, oh, we could have done factoring by grouping, right? Unfortunately, factoring by grouping wouldn't work with this, but maybe you're going to see something where it would work. So this is just a reminder of how to do factoring by grouping. Hopefully I know you did that in Honors 2 Trig, and hopefully you did a little review of that during your polynomials unit last year. But if this doesn't look like something you remember, ask me when we're all back in class and we'll do a problem together. Because could you see you're integrating and then you're like, oh gosh, I don't know what to do, and you could factor by grouping and things would cancel out? Absolutely. So you want to make sure you remember how to do that. Okay, so here we go. I'm looking at this. We know our trig derivatives inside and out. If I'm sitting in a cot or laying in a cot, I cosecant it twice. So we can see our u, we can see our du. It's clear as day. Go ahead, do it, come back. All right, so everybody should have this. Here we go. We had that extra little negative in there. We're okay. All right. So here we've got our tan 5 theta. We can't work with it right now because we've got, we don't have a u. I mean, we have a u. We could make tan 5 theta be our u, right? But there's no du. We could make 5 theta be our u, but that wouldn't work because, you know, tan. So, well,
if I'm tan, I seked it twice, but that's the derivative. So we can't use that, right? So what are we going to do? We already did it. You want to switch it to sine over cosine. All right, so switch to sine over cosine, do it or not. I mean, I think we can skip this one. I'm going to go ahead and do the reveal because we already did it in that first slide. So we would do the sine over cosine, have u be cosine 5 theta. And it's the same thing as what we did in that first slide, except for we've got the 5 theta part. All right, let's see if there's anything else we can do. Okay, with this one, solve the differential equation. I always like it when they show us a differential equation and we remember, oh, that's what, when we integrate, we're just, right, solving a differential equation. So I'm going to get up instead of talking. I'm going to walk over to the screen. I've just been sitting down on my stool. So if we, before we integrated, we would go ahead and swing that dt over here, right? And then we'd integrate both sides and we'd get r is equal to, right, we're just going to rewrite this. Most of the time, we're just used to seeing the integration part, and so it's just a good reminder of what we're doing when we integrate. All right, do I see a u and a du? I do. So here's the deal. We're going to pause. You do not need to be bored by me. Set up your u, set up your du, do your plus c, and then when you're done with your plus c, you want to come back and use, plug your pi in for your x, your 4 in for your r, or I'm sorry, your pi in for your t, your 4 in for your r, solve for c, and then you will have, you'll be done. And so go ahead and do that and come back. Okay. Sitting back down again. All right, so you went ahead, you found your u, you've got your u, you've got your du, all that was so nice and pretty. Let's see, and then, so right here's where we stopped our simple integration, and then we plugged in the 4 for the r, we plugged in the pi for the t, and we said tan of pi is 0, right, because sine over cosine. And then 0 plus 1 is 1. Natural log of 1 is 0, so c is equal to 4, and then we wrote that in. All right, I think this is it. Let's see what else we've got. Oh, we got something. What's behind this yellow? Okay. All right, I think we have 2 more. This one's a good one. And I really want to pause because I know when I'm making this video, it's in 2025, and so my class is going to be watching it together. And this would be a really good one to talk about. So pause, don't do it, just talk about it and come back. All right, hopefully when you were talking about it, you were talking about what could your u be, what could your du be, right? And so hopefully you saw that a good, let me see if I reveal this, if it's going to show too much. Okay, hopefully you noticed, hey, if we just rewrote it, doesn't it make it obvious who our u is and who our du is, right? Because if we pick natural log of x for our u, then our du is right there, right? 1 over x dx. So go ahead, now that we know the u and the du, go ahead and pause it, do it. The hardest part of that was just recognizing who's our u and who's our du. That's it. All right, come back in a second. Okay, so we picked our u as natural log, our du is 1 over x, we set that up. Then we remembered, look, we have a choice. We can rewrite our bounds in terms of u, or you can do what I'm doing here, which is leave our bounds empty when we change everything in terms of u, and then put our bounds back when we substitute in the natural log of x for u again. So then we're just going to go plug in, right? And so let's remember this, the natural log of the natural log of e to the 2. All right, so let's talk real quickly because this is another property. When we see the natural log right here, the natural log of e to the 2, let's rewrite it as log base e, because that's natural log, right, of e to the 2. Okay, I always use the box method. This problem says e to the what equals e to the 2. Well, duh, e to the 2. All right, so that's where it comes from. And then you probably have remembered it when an exponential, see right here we have an exponential caught in a log, right? When an exponential is caught in a log and the bases are the same, everything kind of goes away, cancels out, and our exponent drops down. But that's not really,
you know, a fair way to explain it. It's a fast way to explain it. This is the way that's legal. Okay, that's really what's going on. But can you remember it this way? Sure, absolutely. Exponential caught in a log, bases are the same. Your exponent's going to be the answer. So that's where we get our 2 here. And then once again, this is, well, natural log of e, right? Log base e of e, right? So e to the first power, exponent caught in a log, it's going to be 1. Or you can just remember the property, natural log of e is 1, but that's where it comes from. And so then it looks like I'm just saying natural log of 2 minus natural log of 1 is natural log of 2. Natural log of 1 we know is 0, right? So it's natural log of 2 minus 0, which is natural log of 2. Another way to do that, I love all these different properties. Another way to do this problem from here is we could say that's the same thing as natural log of 2 over 1, right? Which gets us the natural log of 2. All right, so that's fun, whichever way. All right, I think we have one more because, man, I'm getting tired. I'm not even doing the work. I'm just talking. All right, this one is tough. All right, so once you see it and once you do it, it'll be easier the next time you see something like this. And so let me just check on our time right now. All right, so when you see this, it's really hard to know what can we use for our u, what can we use for our du. So when in doubt, right, I look at this and I'm like, let's just take the whole numerator, right? I'm sorry, the whole denominator. Yeah, it wouldn't be helpful to take the numerator. Let's take the whole denominator and let's make that be our u. All right, so let's see if I can do this and not reveal too much. Oh, sorry, I'm going to reveal a lot. So, all right, close your eyes. Okay, I can't. All right, so let's do this. Let's kind of talk through it without me revealing too much. Here's the strategy. Your u is going to be your denominator, okay? And then your du, this is where it's going to be really tricky. Your du is going to have things in it that the integral doesn't have. So you're going to have to get clever. So what I want you to do right now is pause. Set your u equal to 1 plus root 2x. Find your du, and then come back. So pause it. Okay. Once you do that, and I have no other choice but to kind of reveal, let's see if I can, all right, close your eyes, close your eyes. Let's see if I can cover up some of it. Are you still closing your eyes? Okay, you're probably not closing your eyes, are you? But try to close your eyes. See if I can cover the parts I don't want you to see. Okay, there we go. All right, so here's the parts I do want you to see. You set up u equal to 1 plus 2x, right? 1 plus square root of 2x, and then you found your du, and you're like, okay, so I get it. My u, I've got 1 over u, but what in the heck? How can I can't. There's no 1 over root 2x in there. I've already used the 1 plus 2x. So we're going to get a little clever. So we're going to go back here, and we're going to say, well, 1 plus square root of 2x is equal to u, right? So we can isolate square root of 2x by subtracting the 1 from the u. So it is going to look different. We've never done this before. We've used substitution, but in kind of a backwards way from how we're doing it now. So I'm hoping your brains can understand this. So square root of 2x is u minus 1. Okay. Still, we don't want it on the right side. All right. And I got to get up again. I got to write stuff down. All right. So we don't want it on the right side because the right side has to be what I see up here. And all I see up here is that. That's all. I got the dx. Okay. So I've got to get rid of this u minus 1 by multiplying on both sides. All right. So now what I'm going to do is I see the dx. All right. So I see the dx, and I know, okay, instead of dx, I am writing u minus 1 du. Okay, so u minus 1 du. I know it's weird because we haven't really done it exactly this way. And then I already know this is my u. So I'm writing that as 1 over u. All right. From here, we're just going to distribute, and everything's going to be okay. The hardest part was really understanding this part. All right, so go ahead and pause, finish it up, and let's talk about it when you come back. Okay, hopefully you're back. Let me get rid of this.
All right, so there we go. We're just, hopefully you distributed it. You set it up into two separate integration problems, right? And then you just plugged in, you plugged U back in again. So really cool. But I want you to understand, even though you look at it and like, oh, cool, we did it. When you see something like this again, it's going to be hard not to freak out. It's going to be hard to be like, I don't know what my U should be because I don't see a DU. And that's why I want you to make sure you're doing all of the homework and you're coming back. I know some of you have beautiful, beautiful homework, like girl times, girl squared homework. All right, that's terrible to say online, but whatever. It's beautiful. You can come back and study from this again. If your homework, if your notes don't look, very good, and they're not, something you can come back to and use, like change that. Your notes are important. I really am setting you up for success with the notes. All right, sorry I wasn't in class today, or next year, sorry you weren't in class and you're watching this. Hopefully this matches up with what's on the blog, but what's ever on the blog wins. All right, hopefully this all made sense, and I will see you in class.